Let's do it. Oh no.
All right. I know it's been a while since we've had class with all the assemblies and everything, but we need to try to get back into this. So this is the Geometric Series 1, Section 3.5. We had things memorized like the 1 over 1 minus x, what that looked like. Does anybody remember what that looked like?
I do, but I'm not 1 plus x plus x squared plus x cubed.
Okay, and continues on to x to the nth power. Okay, so again, that looked like geometric series, 1 over 1 minus x. That looked like the first term over 1 minus r, so that's why we're relating these two geometric series. So that's what we're going to finish with today. We're going to try to see how this is maybe similar to also geometric series and work through these last few problems before we move on to the last section in this unit. So this problem actually was taken off a 2008 AP exam. So all these portions were on an AP exam. This problem actually was, I believe, no calculator too, so there's going to be some parts down here. But this was taken directly off an exam with no calculator. All right, so part A. Write the first 4 non-zero terms and the general term of the Taylor series for f about x equals 0. So that's telling you center. And they want the Taylor series of this here. So there's actually 3 different ways that you guys now know how to find that. Does anybody remember one of them? That's determining the interval of convergence after you already have the series. So you want to write this out as a Taylor series.
Okay, so we go like f the derivative of
Yes,
f.
that's the first one. So that would be using like the Taylor formula. So that was from a few sections back. That's the first way you could do it.
Next one is we know 1 over whatever 1 minus x. Can't we just like
You can manipulate it.
a little bit?
Yep, you can manipulate it. And I heard Eric say another one. Yeah, you could do long division. So those are the 3 ways you could find that one. You could actually do 1 divided by 1 plus x squared. We are going to use the one where we're actually going to manipulate it. So we know that 1 over 1 minus x, we already said that's the same as 1 plus x squared plus x cubed dot 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 x to the nth. So again, that looks like the geometric series. We have that memorized. It's on a note card. But this is the one that we're talking about. So how can we manipulate this one to look like this one? Need to substitute something. Yep. Substitute in negative x squared. So if we substitute in negative x squared, what would our new series look like? We're still going to start with 1. What's next? Negative x squared. Then what? Okay. Another one? Okay, so that's the first 4 terms. Now we need the general term. Well, we can see what is obviously happening in this one. Alternating. So we know we have negative 1 to the n. It's alternating. We know we have x to some power. What is the power then? Yep, 2n. So that's the first 4 general terms first 4 terms and the general term. And that's all they're asking for part A. So I know it's been a few days, but we kind of remember how we did that. All right, let's look at part B. So part B, this can actually be done a few different ways too. So just because the way that I'm doing it doesn't mean there's not another way to do it. I think there's at least two ways that I know of that this could be done. So does the series found in part A, when evaluated at x equal 1, converge to f of 1? Explain why or why not. So first off, if we just plugged in 1 to this up here, f of 1 would be equal to what if we plug it into the original? Plug in 1 to the original. Yeah, 1/2. So what we're actually going to do is take our series here, plug in 1, and see if they would equal. So 1/2 should be equal to the series when 1's plugged in, where we get 1 minus 1 plus 1 minus 1 plus dot dot dot, general term. Are those ever going to equal each other? 1/2, is that ever going to equal to 1 minus 1 plus 1 minus 1 plus 1 minus 1? No, they're not going to equal each other. So it doesn't seem like it's going to converge to f of 1. But we can actually test this. So like Eric had mentioned earlier, we already have our series from up above, so we can do the ratio test. We can find our interval of convergence. Then we'll know whether that number, f of 1, is within the interval of convergence. So we need the limit. N goes to infinity. Again, the ratio test, you take the absolute value, and you need the nth term, you add 1 to it. So we would have x to the 2n plus 2 over the original, which is just x to the 2n. Again, you don't need the alternator because it's absolute value. When that reduces, you're left with the absolute value of x squared, and that has to be less than 1. If x squared is less than 1, what else has to be less than 1? If x squared is less than 1, I can reduce that to what is less than 1? Anybody? Think about those few problems we went over last week when we had centers. We had centers at 0, we had centers at 1. What did we try to get in the absolute value?
X.
Yeah, just x. If x squared is less than 1, you can say that x is less than 1. So again, we know, thinking back to last week, this is our radius of convergence. We know we are centered at 0 from up above. So we know we're going from -1 to 1. That's our interval. But we want to know, are we actually converging at our endpoints? So this is when we test them to determine, are we diverging there or converging there? So we would take the summation from 0 to infinity, -1 to the n, and then 1 to the 2n. So we're just going to keep getting -1 plus 1, -1 plus 1, -1 plus 1. So does that converge or diverge? Does it ever get closer to a value? No, diverges. Okay. Now you can test the other one just to be sure, -1. So again, -1 times -1, you're still going to get that alternating back and forth. So if you test -1 to the 2n, you're going to get that they both diverge. So your final interval would be -1 to 1, the open interval. The endpoints do not converge. So I'll write it here. The second one, if you would test it, they both diverge. So now the question is actually asking, at that f of 1, does it converge or diverge? Well, at 1, does it converge or diverge? It diverges. It's the open interval. If we found that it converged at the endpoint, that means it would converge here, but we know it diverges at that point. So our explanation, I'm going to write it down below. The answer is no, since x equals 1 is not contained in the interval of convergence. So if they asked you for a value, if they asked, does f of 1/2 converge? With this, based on this conclusion, you could say yes, because 1/2 is within the interval of convergence. So once you find your interval, you know what values if they ask you. So if they ask you more than just f of 1, well, f of 1 and -1 both diverge, but f of 1/2 would converge. And again, we could kind of see this from over here, our original analysis, because we saw that they weren't equaling to each other. And that's all they're asking for part B. So they want to know, did it converge at f of 1? No, because of the interval. All right, part C. I think part C is a little easier. So they tell you the derivative of arctan of x is 1 over 1 plus x squared. Write the first 4 non-zero terms of the Taylor series for arctan of x about x equals 0. So we know the center is still 0. That's important. That means we can use our information from up above because both centers were 0. Again, that's important. If the center changed to 1, we would not be able to use what we had up above. So they're telling us arctan of x is going to be equal to the integral of 1 over 1 plus x squared dx. Because they're telling you the derivative is 1 over 1 plus x squared. Well, we know what 1 over 1 plus x squared is. We found that up above. We found that in the first part. So we need to find the integral of the first part. So again, just rewrite your answer from part 1 down here. Integral of 1 minus x squared plus x to the 4th minus x to the 6th plus dot 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 dx. And again, right now, they're only asking for the first 4 terms, so you don't really have to worry about the nth term. They're not asking about it. So simply, all they want you to do is take the integral of these terms to find your new series. And this series would be of arctan. So arctan of x is going to be equal to integral of 1 is x. Integral of x, negative x squared, would be minus x to the 3rd divided by 3 plus x to the 5th divided by 5 and minus x to the 7th divided by 7 . And again, that's all they're asking for part C. They gave you the key point there. The key point was that the derivative was this. Again, that linked us back to part A. So as long as you found part A, you could use part A and part C. Now again, the way of grading questions like this, if you had gotten part A wrong but used whatever you found in part A correctly in part C, you would get points for that. So just because you can't figure out something in another part, continue on with the problem because you're not going to get docked twice for something that you really only messed up once. Does that make sense? Any questions on part C? Alright, part D can be a little confusing at first, but let's read through it and then we'll kind of explain what it means. So it says, use the series found in part C to find a rational number A such that the absolute value of A minus arctan of 3/4 is less than 1/10. Justify your answer. So before I tell you anything about this problem, what does this seem familiar for, or familiar from? What have we done that's similar to this? What does it look like? Because we have done something that is very similar and basically the same thing within this unit. Not necessarily in this section, but within the unit. Think back to that 3.2 section we were in. When did we do something that looked like this? Okay, that's going to be important with this. Yes? Okay, well, Eric just mentioned something about alternating. So in 3.2, what all did we do with the alternating test? What else was involved with it?
We found the remainder.
Yeah, either the error or the remainder, exactly. Now, that's not the only test we did that with. What was the other one? Yeah, the integral, but we're focused on that alternating series one. That's the one that's going to help us out here. So this whole process right here that we used would be known as finding the error / remainder. That's what we called it before. The error or the remainder. So what we want this error or remainder here to be less than 1/10. This 1/10, this is known as your error bound. Again, that's what we want our error to be less than. We want it to be less than 1/10. When finding the error bound or remainder, this A value that we're finding, this is the approximate value. In this specific problem, the approximate value of arctan. And this value here would be the actual. So taking the approximate, subtract the actual away, the absolute value of that must be less than 1/10. So your error, less than 1/10. Now if you think back to 3.2, they were done a little bit different with each test, but we're working specifically with alternating, because Eric said the series we are dealing with is alternating, so we're going to think about how we use the alternating series test. So think back to the alternating series test. How did we find the remainder, use the remainder, or find the error within that test? I'll give you a minute or so if you want to look back and try to remind yourself, look back at the remainder.
It was like summation of well, we did find like Wait, what is R then?
That's your remainder or your error, yeah.
Okay, so we took the remainder equals an plus 1. Yes, and then we found the actual summation value by plugging in
There should be something with a value being less than a value, kind of like we have less than 1/10 here.
So the summation, or S minus S and N is less than A N plus 1.
Yeah, So what we're trying to find here, we're going to list out a few terms here once we start. And this term A, the approximate value, we're going to find the terms and add or subtract. It's alternating, so we're going to be adding and subtracting until we come to a value that value is less than 1/10. Once you find that value that's less than 1/10, with it being alternating, no matter if you add it or subtract it, if the actual value of it's less than 1/10, the error has to be less than 1/10 because you can't get past that if that value is smaller. So I don't know if we're going to be able to finish, but let's go ahead and start. So arctan of 3/4 that's going to be equal to, well, the first term would be 3/4 minus, it's going to be, let's bring the 1/3 out in front. So 1/3 3/4 cubed plus 1/5 3/4 to the 5th, and we're going to go one more term, minus 1/7 3/4 to the 7th, dot, dot, dot. So again, right now we're just plugging into the arctan of x. We have 3/4, that's what they want to know about, so we're just plugging directly in. Simplifying a little bit, 3/4 is what we get here. Three-fourths, that simplifies to 0.75. Is that less than 1/10? No, so we need to go to another term. For time's sake, I'm going to help you out simplifying this. So this term here simplified would get you to 9/64, which gives you a decimal of 0.14. Is that less than 1/10? No, so we need to keep going. I'll help you out again. Simplifying this third term, you get 243/5120. Again, if you would type that into a calculator, you get 0.047. Is that less than 1/10? 0.047? Yes. So we found the term that's going to be less than this 1/10 that we're looking for. But we're going to have to stop there. We'll finish it tomorrow. Okay, so get copied up to this point, and we will finish that tomorrow.